Greetings everyone, a very warm welcome to sqadia.com. Cells and their organelles perform their roles. And if we talk about nucleus, then let's zoom in to see what's happening inside. Nucleus has DNA, which instructs the production of proteins. Once proteins are formed, they fold themselves into a particular shape to perform their function. But when proteins are misfolded, they paralyze the normal functioning of the body and may worsen over time. Our body's defense system is expert at identifying abnormal proteins. These misfolded proteins are then degraded by proteases, so they cannot harm our body tissues. Proteases are the enzymes that chop up larger proteins into smaller pieces. In this video, we will learn about amyloidosis. Amyloids are referred as proteins with abnormal shape, which then stick together and settle in different body tissues. So, amyloidosis can be referred as a disease characterized by tissue damage due to extracellular protein deposits, or amyloids, which interfere normal functioning. Let's see how these protein deposits form. Well, there are two situations in which protein folding is misleaded. Let's dive into the details. In first case, there are normal proteins, but in excessive amounts, and only a small fraction folds incorrectly. While in the other case, there are abnormal proteins with incorrect amino acid sequence, but they're produced in normal amounts and all of them are having incorrect enfoldings. Now you must be thinking, why misfolded proteins accumulate? The amyloids or misfolded proteins start to build up due to two main reasons. First reason is they are too many or enormous in number. So, it becomes impossible for proteases to handle and cleave them to avoid accumulation. The second reason is the way they are folded in some cases makes them hard to break, or we can say they adopt a sheet-like morphology that is resistant to cleavage and degradation. Amyloids exist in two stable morphologies. First is native form and the other one is beta sheets. Let's discuss about beta sheets and see how they behave. This is the normally folded protein. But if a misfolded protein is excreted out of the cell, and it is quite possible that it attains a sheet-like structure that will auto-aggregate, or we can say clump or stick with other misfolded proteins to form amyloid fibrils, which will be the culprit to hinder the tissue activities. The characteristics of these fibrils are they are rigid, they are insoluble, and resistant to proteolysis. These amyloid deposits can form in many organs of the body, such as lungs, heart, liver, and intestines. Now, if you want to grab more details on types of amyloidosis, hit the play icon of the next part.